Hello, everybody. Welcome back to the Engine Nerds Team 9892 Coding Bootcamp for FTC. In today's video, what we're going to be doing is we're going to be going over basic autonomous for motors and an explanation of what the motors will be doing. So let's get right into it. So you're going to go to org.firstspires FTC robot controller, external samples, and copy one of the files in that folder. Then we're going to bring it back to our team code folder, one right here. We're going to paste it, and I'm going to call it driver or motor example. I feel like that's the easiest name for me to call it because this is a tutorial after all. And I'm going to copy it, or I'm going to create it, and I'm going to do Control A, delete. And the first thing that we're going to have to do is we're going to have to add a package. So package org.firstinspires.ftc.teamcode. And this is where our file will be located, and basically this is how the driver hub knows to pull this specific file out. Next things we need to do is to do import statements. So import, and I'm going to do our linear op mode first. So com.qualcomm.robotcore.eventloop.opmode.linear op mode. That would be one of them. Another one we're going to add is the what's it called? The autonomous. That's also something we're going to be adding here. One right here. And then one more we have to add is the motors. So com.qualcomm.robotcore.hardware.ac motor. And then we should be good to go. So now what we're going to do is we're going to do it at autonomous, parentheses, name equals quote, and I want to call it motor test or motor example. Sorry, same name as my file. And now we're going to go underneath this public class motor example and extends linear op mode. Linear op mode. Again, I make sure to have your curly brackets after. And now we're going to do one more thing. We're going to do at override, and then public class or public void, sorry, run op mode. Parentheses, curly brackets. Now we have wrote our basic or template to write our code. So now what we're going to do is we're going to call our motors. And the easiest way to do it is we're going to do BC motor, motor FL. And we use DC motor to signify that the variable name here is a motor that needs to be used. And again, you can call your motors whatever you want, but because we are using drive motors, or your wheel motors, typically it's easier to do like motor FL, motor BL to stand for front left, back right, whatever you need to stand for. So again, I'm going to do this 2 or 3 more times. Motor FR, DC motor, motor BR, DC motor, motor BL. So that's all this, all the motor variable names. Now what we have to do is we have to set a hardware map. A hardware map is basically the driver hub knowing which motor is which. So you basically tell the motors, oh, hey, this motor is in slot 1 in the driver hub, but the driver hub only knows a name from the code. So how we do that is we're going to do motor FL equals hardware map dot get, and then I'm going to do DC motor dot class, comma, quotation marks, and then I'm going to do motor FL and do these for all 4 motors. I try to keep these the same so I don't lose track of which motor is which. So motor FL is equal to motor FL, and so on and so forth. You can technically change it. You just have to remember to change it in the driver control app. And we're going to do motor FR equals hardware map dot get DC motor dot class, and then quotation marks motor FR. Make sure you have your semicolons after all of these. That's how you end up with no errors. And motor BL equals hardware map dot get DC motor dot class, and quotation marks motor EL, and then you're going to put your semicolon, and then motor BR equals hardware map dot get DC motor dot class quotation marks motor BR. And I'm going to give you guys a second just so you can see exactly what I typed. Okay. Moving on from this, we're going to be doing motor directions. So motor FL dot set direction. I'm going to set the left sides to forward and the right sides to backwards, which should orientate your robot to drive in a forwards direction. And note, you can change these to like all forward and it'll be spinning. You can change it to some left, some right, and it will move in different ways. Some of it may strafe, some of it may move in diagonal pattern, whatever it is. Just again, play around with it. It is interesting enough to understand how the robot moves through the code, or how the code works with the robot. Now we're going to do motor FR dot set direction reverse. And now we're going to do these for the back left, and we're going to set it to forwards. We're going to do it for the back right and set it to reverse. Give you a second so you can see what it looks like. DC motor simple dot direction dot forward, and it looks like that. Also, I don't know if there is an error with DC motor simple dot direction, you can import it up here using import com.qualcomm.robotcore.hardware.dc motor simple. And typically, if you just hover over it while it's in an error, you can do Alt Enter and it will import it for you, or you can type it out. The next thing we need to do is set the motor power. So motor FL dot set power. Now I'm going to set to 0 to start because again, we have not even pressed play yet. This is all in the initialization phase. So motor FR dot set power 0. You keep motor EL dot set power to 0, and motor BR dot set power to 0. And basically what it does is it tells the motor how fast to run. So if you set it to 0, you're not going to have any power going to the motor. And that's what we want for initialization. We don't want to move during initialization phase. Now what we're going to do is we're going to move on to our wait for start. So again, this is right now, all of this is in the initialization phase. Anything after the wait for start is the play phase. So now I go here and we're going to do motor FL dot set power, and I'm going to set it to 0.8. The motor power ranges from -1 to 1. Negative just reverses the direction it's going. So I always keep my values positive, but again, it makes it a little bit easier just to work with your numbers. And then we're going to do motor BR or motor BL dot set power to 0.8, and we're going to set all of them to 0.8 just to make it a little bit easier. Motor FR dot set power to 0.8, and then motor BR dot set power to 0.8. So again, right now, what this code is saying is run at 80% power for eternity. We want a way so it can just stop after a certain amount of time. So what we're going to do is we're going to add a sleep command. A sleep command basically means that the robot is not going to do any other action for X amount of time. Note that this is in milliseconds, and basically 1 second is 1,000 milliseconds. So right now, the robot will not do anything other than drive the robot at 80% power in a forward direction for a second. And after, but okay, so what happens if we just do nothing after, right? It still runs forever. It doesn't just stop all the code because it slept. It didn't do any other actions for a second. It's still running the 80% power. So what we're going to have to do is we're going to have to basically copy and paste this motor FL, motor FR, motor BL, motor BR set power to 0 and put it after the sleep command. And now you have a fully working autonomous. It drives the robot on its own for a second and then stops. And with that, that's going to conclude the end of this video and the explanations of all the stuff that is motor related. I hope you guys enjoyed and find this useful. And I'll see you all next time. All right. Bye bye.